Okay, so now we're doing question 3 of interactive lesson 3C. And this is the goal of this lesson is to understand how the output of a nation is measured. And you can watch this video to kind of get a feel for what it is. You can also read the chapter on GDP. Questions 1 through 4, I want you to try those on your own, right? They're pretty basic questions. Some of them are kind of challenging. And then where I'm going to start is, and there's no pin number for this one because we're not going to do this in class, right? The screen is too small to do a spreadsheet model. Okay, so I'm going to try to remember that in the future. So instead, it'll be part of your homework, right? The table below reports Caucasia's nominal GDP and GDP implicit price deflator by year over a 9-year period of time. We're going to use these values to compute real GDP and the economic growth rate, right? So what we need to type these numbers into here. 9.937 and then 89, right? Now I'm going to go ahead and fill the rest of this in. I'm going to spare you those details. Okay, well, I got the numbers in from my table over here, right? I got my numbers in. 91.8, 92.8, all the way down to 109.7. Notice the deflator. The deflator is a broader price index. The CPI is a limited number of goods and services in the economy, right? That's a typical urban consumer will purchase. The GDP deflator is a broader measure of prices because it includes all final goods and services produced within the boundaries of the United States. All prices, not a subset, but all of them, right? And these are final goods and services, right? The nominal GDP is the value of firms, all the firms in the society, the value of their outputs priced in 2015 prices. And notice that nominal GDP goes up 9.937 in my model, 10.470 in my model, right? Why is that? Because maybe prices are rising, which this is saying, right? Prices are rising. It also could be due to the fact that firms are producing more, right? So if firms are producing more and prices are rising, nominal GDP will go up. So what we have to do is we have to figure out how to strip out inflation from nominal GDP. And when we strip out the inflation from nominal GDP, we get something called real GDP, right? And remember what I said about a price index. This is a price index. It's in percentages. The government doesn't really tell you that it's in percentages, right? It just reports them like this. This is actually 0.89. This is actually 1, right? The base year of the deflator in this example is the year 2020. Why do I say that? Because the deflator, the price index, is equal to 100 in the base year. So the base year has to be 2020 in this example. Again, because the price index, known as the GDP implicit price deflator, is 100 in that particular year, right? So what we're going to do to calculate real GDP, to strip out the inflation, get rid of the inflation in nominal GDP, we're going to divide nominal GDP by the deflator. And then the deflator, again, is in percentages, right? So we have to convert it back to a decimal. Since we're dividing by the deflator, we're going to multiply by 100 to get rid of the decimal place, the percent. Okay. So notice that nominal GDP is 9.937. It's 11.17. It's higher. So what we've done is we've valued it in $2020, right? By dividing this by that, another way to think about this too is we can do this. Let's back up here real quick. Okay, so we can get rid of the dollars. Let's just do like we did with the hamburger that we did in the previous example. If I divide this value in billions, $9.937 billion, those dollars are in 2015 dollars, right? Those are in 2015 dollars. We want to value it in 2020 dollars. So I can divide by the deflator in the year 2015. That means this value no longer has any units, right? No longer has any units. But what we want to do is we want to value it in 2020 dollars. So I can multiply this by 100. Okay. So remember what that does. It gets rid of the 2015 dollars and then prices it in 2020 dollars, right? So instead of typing C8, I'm going to type 100, right? So this is going to be the value of GDP in 2020 dollars, right? 2020 dollars, not 2015 dollars. Do the same thing for the year 2016. This is in 2016 dollars. I want to value it in 2020 dollars. I don't want 2016 dollars. I want 2020 dollars, right? So notice what I did here. I divided this value that's in 2016 dollars by the deflator in 2016. And then I multiplied it by the value of the deflator in 2020. So I'm giving nominal GDP, I'm getting rid of its 2016 dollars, and I'm giving it 2020 dollars. I'm not valuing it in 2016 dollars. I'm valuing it in 2020 dollars, right? Okay. Notice that everything before the real GDP values before the year 2020, they're higher than their corresponding values in nominal GDP, right? So we've inflated this 2020 dollars. We've inflated this value to 2020 dollars. We inflated this value to 2020 dollars. We inflated this to 2020 dollars. We inflated this to 2020 dollars. Notice that these two things are the same thing, right? The year 2020, because 2020 is my base year, nominal GDP in the base year is equal to the real GDP because we're dividing by 100 and multiplying by 100, right? Dividing by 100 and multiplying by 100. So I can say that this is nominal GDP and I can say it's real GDP. Right? And now notice what happens. Now we're deflating every nominal GDP value thereafter, right? Nominal GDP is greater than real GDP the year following the base year, right? We're deflating. That's why it's called the deflator, right? Okay, so now these values, we can think of these values as just, if these values are going up, if these values are going up from year to year, that means firms are generally producing more. And we've accounted for the prices. So this is the value of GDP in 2000. This is the value of output year 2015, valued in 2020 dollars. This is the value of that same output in 2015 dollars. This is the value of 2017 output valued in 2020 dollars. This is that same output valued in 2017 dollars. See how that works? So we've stripped the inflation out of the GDP number. So we can think of this as the output of the economy, right? I'm going to calculate the growth rate. The economic growth rate for the year 2016 is real GDP in 2016. What it is, what real GDP is in 2016 minus what it was the year before in 2015, right? Divided by what it was. I'm going to turn that into a percent by multiplying by 100. Yep. I'm going to do it again, right? Do it again. Okay, I want to know the economic growth rate, which is just the percent change in real GDP. So this is what real GDP is in the year 2017. This is what it was in the year 2016, the year before. We divide it by what it was the previous year. We're going to convert it into a percentage, right? And I'll shrink it down to 2 decimal places. And then I'll just drag this little box right here down. I'll drag this box down to here. Okay. So notice that we have a decline in real GDP from 2017 to 2018. Why? Because in 2018, GDP was or is $11.630 billion. It was 11.788. So that difference is negative, right? So we interpret that as GDP fell by 1.33%. Here, GDP rose 2.15%. Here, GDP rose at 3.35%, right? 2017 to 2018, GDP fell by 1.33%. 2018 to 2019, GDP rose by 0.11%. 2019 to 2020, GDP rose by 0.2%. We don't have a lot of economic growth here, do we? Right? We don't have a lot of economic growth. In the year 2023, we have a pretty large economic growth rate, right? Not extremely large. I mean, a good economic growth rate would be three or four, right? But anyway, so it's positive because real GDP is 12.172 in year 2023. It was $11.943 billion the previous year, 2022, right? So going from 11.943 to 12.172, that's a 1.92% increase. And the average economic growth rate over that time period is 1.09%, right? So let's go ahead and enter those numbers in. 11.165, 11.405. The economic growth rate is 2.15%, right? And then in the year 2017, real GDP is 11.788, and GDP grew from 2016 to 2017 by 3.35%. That's the highest growth rate, right? Okay, what I'm going to do is I'm going to put this on pause. I'm going to spare you the details. I'm going to go ahead and fill in the table. Okay, I went through and I entered all my information in from my spreadsheet into my problem, and I got all the correct answers, right? That's pretty cool, right? And then all I have to do now is type in the average economic growth rate from 2016 to 2023, and that would be 1.09%, right? So it's pretty anemic growth. We had good growth in 2016, good growth in 2017, okay growth in the year 2023, but other than that, it's been pretty lackluster. And then we had a decline in output in the year 2018, right? Now, Caucasia's 2019 economic growth rate is what? 2019 economic growth rate is 0.11%, right? And it's 2019 annual inflation rate. Now, the annual inflation rate, remember, inflation is what? Inflation is the percent change in the price level. Remember, I can use the deflator. Deflator is a broader measure of prices, right? But what is the price level according to the deflator in the year 2019? Well, in my case, it's 97.5. I'm going to subtract that from what it was the year before. I'm going to divide that by what it was the year before, right? So what it is minus what it was divided by what it was. I got to convert it to percent, so I'm going to multiply by 100. Okay? My inflation rate is 2.96%, right? My inflation is 2.96%. Okay. Now, subtracting the inflation rate from the economic growth rate equals what? If I subtract the economic If I subtract inflation from the economic growth rate, I get a negative number, don't I? Subtracting 2.96 from 0.11, and I get a negative number, 2.85. Okay. Yep. Now let me show you this. Okay, so this is let me calculate nominal GDP growth. The growth rate of nominal GDP is what it is in the year 2019. It is 1.352. I'm going to subtract it from what it was in the year 2018, year before, right? And divide by what it was previous year in 2018. I'm going to multiply that by 100%, right? 100. Okay, my nominal GDP growth rate oh, let me put this in pause for a second. Okay, I found a typo in my algorithm, so I had to fix my problem. Okay, so the nominal GDP growth rate equals the inflation rate plus the economic growth rate. So subtracting the inflation rate from this economic growth rate, I don't want to subtract them. I actually want to add them. So I edit this already, and I flipped the sign on this. So let's go ahead and refresh this. Click refresh up here on your Google browser, and then click resume. And then go to question 2 or 3. Sorry, question 3. Okay, now it says what? Adding the inflation and economic growth rates should be, change this. Okay, so again, the inflation rate is the percent change in the GDP deflator for the offending years, right? 2018 to 2019. So it is 97.5. It was 94.7. So you take that difference, you divide by 94.7, and you get an inflation rate of 2.96. Now, because nominal GDP growth equals inflation plus economic growth, roughly, right? I wanted to add the economic growth rate to the inflation rate. So when I add the economic growth rate to the inflation rate, I get 3.07. And then when I calculated the nominal GDP growth rate, I have what it is in the year 2019, $11.352 billion, minus what it was in 2018, $11.014, divided by what it was, $11.014 billion, multiplied by 100, I get an economic growth rate, nominal GDP growth rate, 3.07%. This should be 3.07%. I'm going to re-enter it, 3.07%. Okay, there he goes. All right, cool. All right, so the sum of economic growth in the year 2019 and the inflation rate equals nominal GDP growth rate. See that? But what that's saying is, like I said earlier, these are going up probably because prices are going up and quantities are going up, right? And so we should expect it to be really close in numerically. When you're looking at the data itself, it may not equal, that sum may not equal nominal GDP growth rate, but theoretically it should, right?